Welcome to another episode of Data in Charge. Today we'll be talking about trade events processing in high scale, 300,000 transactions per second, without missing a tick. My name is Adam Majcher. I'm a pre-sales engineer here at Volt Active Data. And this is our agenda for today's meeting. So first we'll describe what kind of problem we are actually trying to solve. Then what is VWAP, which is volume weighted average price. A little bit about the architecture of the solution, what kind of components we are using, jumping into live demonstration to show you how it actually works on the cloud, and a short summary at the end. So what are the trade processing challenges? Of course, everything what is related with money is really sensitive for the end customers. If they don't have access to their money-related assets, they tend to be really angry. So all kinds of these trade processing systems need to have very good stability, accuracy, and reliability. We have there, of course, a lot of demand for the real-time data processing, because all of these take profits, stop losses. They are basically decisions based on the incoming trade traffic. On top of this, we have quite big spikes in this kind of processing systems, because there is some kind of event related to the specific asset, like the financial reports, publication, announcement of some big deals for the companies, and then the traffic can actually spike 10 times, even 100 times of the regular volume. And last but not least, we have some regulatory compliance, which needs to be there. So all the logs, all the history of trades needs to be there for possible audits later on. What is VWAP? VWAP is volume weighted average price, which represents a little bit like the true average price, which takes into account also the volumes, not only the price of the specific trade. So this is used by the institutional traders, by the algo trading software as well, just to assess the specific price of an asset and then make decisions based on it. The formula is pretty straightforward. We are multiplying the price of the trade against the quantity of the trade, then dividing it by the quantity of the trade itself, and we are getting the result of the VWAP. You have the example below, so you can see that if you have 100 shares traded at $50 and then 200 shares at 51, the VWAP is actually 50.67. While without the weighted price, it would be like 50.2. So as you can see, the higher volume is actually affecting it more. It is quite frequently anchored to the session, because the longer you go from the start of computing it, the lower impact the new sample has. So most of the use cases, in most cases, this VWAP is actually computed from the start of the trading session and then finished at the end. Why VWAP is actually a good benchmark for this kind of systems? First of all, we got this inquiry from our customer, so they wanted us to do this as a kind of POC to show that the system is capable of processing these many events. So this is very, very good indicator when the real customers requiring this kind of benchmarks. But it is also related to the stateful computation, which requires continuous aggregation, right? So all of this data coming in, it needs to be processed very fast. And this indicator will change with every trade event. This is also producing the realistic production workload on this kind of systems, and can show that the whole processing data stream is good enough to deliver all of these computations and show the capacity of the system. So this is the architecture overview. We have the traffic generator, which is generating the trade events pushed into the 3-node Kafka cluster, from where we are ingesting it into our V4SD cluster, which also consists of 3 nodes. We have S&P 500 tickers there ingesting data at 300,000 transactions per second. V4SD cluster is 3 quite beefy servers, and then from there we can move it to the data lake, because as I said before, VWAP is usually anchored at the beginning of the session, and at the end of the session we can just archive all of these trades into some long-term storage. Okay, now let's jump into the live demo. Okay, here we are. So we can see we are injecting here around 300,000 transactions per second. The total is already around 70 million. I let the demo run for a few minutes before, and we have the transaction latency, which is way below 10 milliseconds. Here you can see the live chart, which is showing the actual stock price, and the VWAP indicator below with the black line. We can change it, of course, to any of the S&P 500 tickers. The system is just feeding all of these events with 300K per second. This is based on some historical data from the stock exchange. So it is showing actually the quite real movements here. And this is the demo architecture again. So we have this deployed on the GCP cluster, and the traffic is flowing through Kafka, V4SD, and then at the end of the session it can be exported to the data lake. Okay, so it was the live demo of our system. What are the key takeaways here? First of all, we have full ACID compliant transactions. Each transaction has the serializable isolation level, which is really important for money related transaction processing. We can do this with ultra low latency, so the latency is lower than 10 milliseconds, even with this high volume of 300,000 transactions per second. The deployment is really easy. You can do it on your cloud, private cloud, public cloud, on-premise as well. So we are very flexible here. We have full support for Kubernetes with Helm charts. So this all can be easily deployed within your network. And we have, of course, the flexible event processing, which handles both stateful and the stateless streaming scenarios. If you'd like to try it out, you can go ahead and open this link here, where you'll see our TriVolt page, where you can see and download our products for the developer edition. There will be also a platform where you could run the cloud demos shortly, probably like in 1 month. And you can just check it out there. And if you have any questions, you can reach out to me directly over email or via LinkedIn. I'll be happy to answer all of your questions. Thank you, and see you next time.